Hello everyone. We're now going to study about motion in one dimension, but specifically we'll understand what is the definition of one-dimensional motion. One-dimensional motion is that motion that happens along a straight line. So for example, if you have a bus that's on the road, you can see that it's going in a straight line, and this is an example of one-dimensional motion. Even the example of a ball falling under gravity is an example of one-dimensional motion. So in this way, we see that one-dimensional motion is all around us. To understand one-dimensional motion, we'll see that every object moves along the path at a given instant of time with its position changing as a function of time. So you can see this person on a bicycle is going from one position to another, from one instant of time to another instant of time. It's precisely because of this relationship between position and time that we say that mathematically we can express position as a function of time. That is, we write x as f of t, which is function of time. So this is what is meant by one-dimensional motion. Let's now understand some concepts of one-dimensional motion. For example, the first one is distance. Now what exactly is distance? Distance is the length traversed by an object. It is the actual length of the path covered by a moving particle in a given interval of time. So if you have a child that is racing on a racetrack, the path traversed from its initial point to the final point is exactly what we call as distance. What are the units of distance? Distance has the units of meters in SI system and centimeters in the CGS system. The dimensions of distance are m0, l1 and t0. But what is most important about distance is that it is a scalar quantity. That is, direction is not involved in the definition of distance. Displacement, on the other hand, is a different quantity than distance in this exact way that it is not a scalar quantity. For example, displacement is a change in the position of the body or particle in a particular direction. And that's why we say displacement is a vector quantity. And this vector is drawn from the initial position to the final position. For example, take a look at this train going down a roller coaster track. It begins at some point, after some time it's at a different point, and finally it reaches this third point. So what is the displacement in this specific example? It's the vector drawn from the initial position to the final position. And as such, displacement is a vector. So distance was a scalar, but displacement is a vector. However, displacement has the same units as distance. It also has units meters in SI system and centimeters in CGS system. Its dimensions are also the same, m0, l1, t0. But like we just discussed, displacement is a vector quantity. The key point about displacement to remember is that if you have multiple displacements, for example S1, S2, S3 in multiple directions, the total displacement is a vector sum of all the displacements. For example, if I begin from a point and I have multiple displacements in different directions, as you can see. So let's say it's S1 in one direction, S2 in the other direction, S3 in the third direction and S4 in a fourth direction. The total displacement is a vector sum. That is, the vector drawn from the initial position to the final position will give you the total displacement S. And in this way we can see that this is the biggest difference between a distance and displacement. Distance is scalar while displacement is a vector quantity. Thank you.